Now we can going to discuss about the product, a new control for bidirectional wireless power transfer system. Now we going to discuss about the abstract of our project. The wireless power transfer in promising technology for supplying power as various applications with no physical contact. Recently, bidirectional power transfer system are gaining a popularity for vehicle to grid and grid to vehicle applications, which essentially require power for transfer in both directions. However, the bidirectional wireless power transfer system are complex in nature and requires sophisticated control strategies to provide the synchronous as well as regulated the power flow for two sides. This paper proposes a new controller that use the measure active power and reactive power at the resonant network of bidirectional wireless power transfer system to regulate the power flow in both directions while providing the synchronization between two sides without dedicated communications and interface the control power of transfer aspects. The current source of WPT systems allows the bidirectional power transfer between the grid and any number of independent loads, consideration more suitable for V2G facilitations, and a grid tied bidirectional converters to employ the control the grid current as well as maintain the constant and soft the DC link voltage of for proposed bidirectional systems. The example for single pickup load. This is an flow diagram of our product. First we can see the AC grid. The AC grid is an interconnected network delivering electricity from producers to consumers. It consists of generating stations to produce the electric power of high voltage transmission lines that carrying the power of the distant source to demand centers and distribution lines that connected the individual customers. The AC converters of approximately sinusoidal input currents and the bidirectional power flow can be realized by coupling pulse width modulation rectifier and pulse inverter to DC link. The DC link quality is impressed as an energy storage element of common both stages, which capacitors see for their voltage of DC link. The current of DC link is primarily to pulse rectification mode of sinusoidal AC line current drawn the which phase and antiphase energy feedback system to corresponding the AC voltage line. Next we can see about the bidirectional AC to DC converter. The single phase bidirectional AC to DC converter is used as interface between AC grid system and DERS to maintain a good DC voltage regulations and AC current shopping. The topology of single phase bidirectional converter allows the bidirectional power flows between grid DERS and the grid AC grid systems. In single phase bridge converter achieves the bidirectional power flows in the renewable system. A PWM strategy may apply to accomplish the voltage regulation of DC side to current shopping of the AC side. Generally, PBWM and UPWM strategies are often utilized in single phase AC to DC converter. Between simplified PWM strategy is proposed. The proposed simplified PWM only can changes the switching status for active switches. Next we can see about the bidirectional wireless power transfer systems or in whole system. This high frequency DC to AC converter is an mostly high frequency in our interface with our transformer. This transformer is a loosely coupled transformer. Is a primary winding of DC to AC converter and is connected to secondary windings of high frequency AC to DC converter. This conversion is majorly important for wireless power transfer system. This conversion to efficient our output vehicle to grid monitoring system. Next we can see about the electric vehicle. Electric vehicle is one of the devices and acts on load This is an to use the energy and discharges the energy. Next, we can see about the running procedure for our product. The proposed system implementation done in MATLAB version 2013A. First, you open MATLAB file window and create a new model file. After creating that, arranging elements as per the circuit diagram. The output waveform will corresponding to the scopes in the circuit diagram. First, we can see the output of electric output. This is an AC grid voltage of an input sinusoidal wave for corresponding to 220 amplitude of sinusoidal wave. This is an grid inverting voltage of sinusoidal and a square wave of this model. This is an transformer secondary side of the output of the square wave on a long amplitudinal wave.